Hi class. In this video, we're going to look at how to visualize data whenever we're planning to do an ANOVA and check some of the assumptions using those visuals. So here you see that I have the ANOVA data. This is formatted slightly differently than the other video in that I've changed 1, 2, 3 to be public, religious, and then independent. So I basically just put in the actual labels. By using those labels, it works a little bit better when we go to do the box plot here in a moment. It'll pick up, oh, hey, this is a categorical variable more quickly. So I'm going to highlight the data that I want to use for this. So I have 16 students. I have the school type, and then I have their SAT performance on the math section. I'm going to go into Insert, and I can go to box and whiskers. So when I look at this box and whiskers, I could shrink this down a little bit just so I can fully see it in the window. And what I see is this blue line is the median. I have the interquartile range, and then I also have the upper and lower limits there. And I can click on each of these individually, right click to go format the data series. And I can see that it's supposed to show outliers if there are any. So that would give me a good sense about that. And for the quartile calculation, it's currently exclusive of the median. Since there's so few scores, I probably want to make sure I include the median actually in the way that's done. And when I look at it that way, I suddenly see, oh, hey, there's this outlier on the public group. So we have one student, I can see them over here, scoring a 610. And that student's doing quite a bit better than the rest of the students in that group. That being said, 610 is a possible score on the SAT. Consequently, I would probably keep it in, but at the same time, I know that that's potentially adding variability that won't be well explained looking at these different groups because that student doesn't seem to completely fit with that group. So when I look at this, I get a sense about the average performance by the median. I get a sense about the variability in the data. I can also begin to look. This one being wider may suggest that there's more variability in this group than in maybe one of the more narrow groups. Now it's not a test, but it begins to give me some things to think about. And then maybe I want to do a Levene's test in order to check variance and make sure that that assumption of homogeneity of variance is met. Going to delete the box plot. You can also use this to do histograms. Importantly, for an ANOVA, you really want to do a histogram for each group separately because it's not about the distribution of the scores. It is about the distribution of the error. In this model, in this ANOVA, the group, public, religious, independent, the type of school, is one of our variables of interest. And we want to know about the variability of scores around the average in that group or within that group. And so because of that, we want to do it by group because we can, some of the variability that's due to the group we can account for. That is not error. So when we look by group, this is variability of the individual within this school type that is not explained by the type of school they attend. So I'm going to go to Insert. I'm going to go here and click on Histogram. Now, the initial histogram that I get is not super useful. So when you create a histogram, you end up binning the data. So this data on our X variable is continuous data, right? It's a scale score from the SAT. Well, to make the chart more readable, it has made these kind of bins or categories where we have scores of 450 to 580 and 580 to 710, but that really doesn't do justice to the nature of the data. Now, admittedly, we have very limited data, so we could end up with bins that really only have 1 or 2 people in them. That being said, typically we would want to make these bins a little smaller. So if I right click on the x-axis and go to format axis, I can either control the bin width or the number of bins, either one of which, by increasing the number of bins or narrowing the bin width, I can make it bin the data differently. Let's look at, we know that SAT scores are on increments of 10. You can make a 170 or a 180. So let's bin these with the width of 10. When we look at it that way, we see that we have a couple of individuals who have a score around 450, 460. We have a couple of individuals here. And then once again, we see that outlier. There's nobody between about 500 and 600. And then we have this one person doing quite a bit better than everybody else in the group. So this helps us see the distribution of the data. It also is going to help us to identify those outliers. So again, this over here is the frequency. You've seen a histogram before, but now you've seen how we can make one by group in Excel. And then if we wanted to make one for the next group, we would just highlight the individuals, the students who are in the religious school, go to Insert again, create a histogram. Once again, we are going to have bins that really are larger than what we would probably ideally like. And so I'm going to click on the X axis, go to Format axis, and I'm going to say, you know what, we already used 10. To make it easier to compare this distribution to the distribution we saw, we can do that. And we see that this distribution may be a little bit different. The min, the max may be relatively close. I'd have to go back and double check that. But we don't have this huge gap in between here with nothing going on. Now, once again, we only have 5 students for each of these schools. Probably not the best data to begin to look at normality, but what we're trying to do now is just introduce these ideas. How do I visualize the data? In this case, using box plots and histograms. And then how do I use those visualizations in order to begin to think about those assumptions, like homogeneity of variance, meaning that from one group, public, to the next group, religious, is the distribution of data relatively comparable? Is the variance in one group similar to the variance in another group? Now we can do a statistical test of that, Levine's test. We're not going to delve into that. Right now, what I'm trying to do in Introduction to Statistics is introduce these ideas, get you familiar with them, get you familiar with the fact that you should be looking at your data, paying attention, familiarizing yourself with it, looking for these things, and then in later courses, they can build on that and delve into this further and go, how do we check it more formally through things like the Levine's test? And if we violate that assumption, what do we do? How do we deal with it? And there are completely separate tests like Kruskal-Wallis that will allow you to deal with some of these assumption violations. So in this case, what we're really trying to do is look at the distribution. Is it relatively normal by group? Homogeneity of variance. Are our groups relatively equal in their variance? Do the distributions look kind of similar? And then also identify some of those outliers and begin to think, is this person, should they be included in our data? And potentially those outliers are scores that are nonsensical. If you had an SAT score below a 200, well, that's not possible. We would throw that data out, or we would try to replace it with the correct information because that information is erroneous. In our case, all the scores are possible scores. Probably we're going to keep them in, but at least now we're more familiar with the data, what's going in on the data, and what does the data look like.